Good morning, good afternoon, and welcome to the latest installment of the Kaiko Systems webinar series. This one is all about practical AI transforming maritime inspections. My name is Nick Vaughan, and I'll be hosting this webinar alongside my colleague Emir Kosu. Before we get into introductions, just a few housekeeping tips. There'll be a number of polls during the webinar, and you'll see these pop up on the bottom of your screen. It'd be great to get your input on these so we can really focus the content on the webinar on the areas that are of interest to you. And we've reserved plenty of time at the end of the webinar to answer any questions you have. So please enter these in the questions tab. Again, you'll see this in the bottom right of your screen. Now, let's move on to the introductions. If you've watched any of our previous webinars, then you'll already know me, but for any newbies, I'm Nick Vaughan, the head of maritime here at Kaiko Systems. My background is technical, so I'm formerly an engineer, previously spent 12 years with Lloyd's Register working on new construction, existing ships, digital systems. Here at Kaiko, I head up the maritime team, so really focusing on the domain expertise within the company, and how we bring that expertise into the company and across the product. This time in this webinar, I'm really excited to be joined by my colleague Emir, our senior AI engineer, but I'll stop talking and I'll let him introduce himself to you.
Thank you, Nick. Hello, everyone. Good morning and good day for some of you. I'm the senior AI engineer at Kaiko, as Nick introduced me. I lead the AI development of our company, where I focus on designing and building practical AI products for vessel inspections. My background is actually in academia. Before joining Kaiko, I completed my PhD in machine learning. My research was focused mainly on developing neural network algorithms for modeling quantum chemical systems or complex physical systems. I have more than 7 years experience in machine learning and AI, both in academia and industry. And after I finished my PhD, I joined Kaiko because I wanted to use my technical expertise in AI for creating real-world impact. Kaiko has the mission to make AI impactful in the maritime industry, and I try to help the company achieve this goal by building smart tools. So I'm really excited to be here today. And before further ado, let's get started with our webinar. And we wanted to start with a very simple question. So what does AI actually do in today's inspections? We wanted to start with this question because we saw that people lack a clear definition of AI in the maritime industry. And there are some common misconceptions. At Kaiko, we are not here to sell fantasies. We are focused on delivering practical, real-world AI solutions that are already in use on many vessels globally. That's why we thought it would be helpful to start with defining expectations and realities in today's maritime world. So the first and maybe the most common misconception, you all know that AI will replace the crew. In reality, however, it doesn't look like that. AI cannot inspect a vessel on its own. That's still very much the job of the crew members and engineers. And instead of a replacement, AI acts as a smart assistant. It checks and verifies your input, it highlights and detects patterns, and it eliminates the guesswork. More, and maybe the most importantly, it saves you time. Time that you should use focusing on the higher value parts of your job. So AI in the maritime is not about full automation, it's about augmentation. So that's really important. We need a human in the loop. Second misconception is that one magic AI solution fits everything. So you all know probably maritime operations are far too complex for a blanket approach. So there is no generic model that you can take, plug into it, and in any vessel ecosystem and expect to get good results. Conditions and inspection routines all vary significantly from vessel to vessel, or even from vessel structures to vessel structures. So in the maritime, your AI needs to learn this context. And this can be done by fine-tuning or reinforcement learning to create maritime aware models. So this is an important step. And finally, the third misconception is that it's a magic button. Again, you turn it on and instantly you get accurate, flawless outcomes. But in reality, just like a new crew member, just like a junior who joins the AI team, so joins the maritime team, your AI needs to learn, adapt, and improve, right? With the real world feedback. The power of machine learning lies in the feedback, like human beings. So these systems need to make errors, need to detect, and we need to detect these errors. And our models at Kaiko continues to learn from our customer feedbacks. so that we can stay practical, precise, and valuable. So, Nick, from your experience, why do you think it's so important to separate the hype from the reality in the maritime industry, and how should we set and manage these expectations?
Yeah, I mean, I think this is the perfect start to the webinar, really. And as we said, it's clearly setting these expectations and really grounding this in reality. And this like further reinforces Kaiko's approach, right? Like not replacing the humans, but really supplementing it, making life easier for them, both ship side and shore side. And then also this kind of domain expertise element, right? Not applying just something generic. And that's where, my team is working really closely with Amir and the AI engineers to make sure that we have that domain expertise clearly embedded in any of the tools that we build within the system. And yeah, the continuous improvement side of things, it just gets better and better. It's finding out where the problems are, tuning it, and really making sure that it has that contextual relevance and is really providing kind of let's say accurate results that have relevance to our users. And I think this is a great point to just launch our first poll and get some interaction from the audience as well. So it'd be really interesting to know from everyone on the webinar. I mean, are you using AI tools in your normal work? So you should see the poll pop up in the bottom right. And if you can open that up and you'll see the options. So people are using that daily, occasionally, maybe you're just experimenting, or no, you're not using AI at all. So if you select the option that's relevant for you, submit your vote. It'd be really interesting just to learn a bit more, understand, are you guys already using AI? Alrighty, we've got some results coming in. Let's just give it a few more seconds. Okay, and yeah, if you want to, you can also in the chat area drop the name of any particular tools you're using, whether they're domain specific or general, and we can talk about those a bit more as well. But I think the results are in there. So what we can see, occasionally, now with 41%. People occasionally using AI tools, 33% yes daily. So I think we can see that there's already this kind of level of adoption, and really even with the experimenting, I think by far and away we can see that most people are already using that, and I think that's a great starting point, right? And we're only going to see that number increase further and further as these tools are further developed, further implemented in the systems that we all use, and that's certainly the approach that we're taking here at Kaiko.
Yeah.
Maybe that's a good point now to talk a bit more about kind of our general philosophy, right? So as we've kind of talked about, AI builds on top of everything that we already have, and it really reinforces Kaiko's philosophy when it comes to data. So from day one, we've really focused on building this structured data set that's vessel specific. So these vessel specific models, and ensuring that data is then standardized across your fleet. So making sure that it's structured, standardized, and you have that data at scale. And this then removes those data silos and removes those duplicated workflows where maybe things are being checked multiple times on board. And really, this is the point where it allows you to then identify any trends, identify any issues, identify any anomalies. And this is the really important element. And this is where, as we'll show further as we go through the webinar, AI can really provide a lot of value here. And that's then also where we look at how we automate these routine tasks. Again, identify what's happening, look at which parts can be automated. And as Amir mentioned, allow kind of the crews and the shore team to really focus on the higher value elements. And really the point we want to get to and where we're adding the value is making sure this is all actionable. So we have these large amounts of data coming from every vessel in the fleet, inspections being carried out on this routine basis. But what's really important once you've identified these issues, trends, and anomalies is what you need to do, providing these actionable insights, summaries, so that really can focus on exactly what needs to be done, prioritize these tasks accordingly, and really ensure that the most value is being added by every member who's involved in that work.
Yeah. Thank you, Nick. And yeah, after reviewing our company philosophy, maybe it's a good time also start to take a look at our AI products in live. So in Kaiko, we can classify our AI products in two main categories based on technologies we use. So we have computer vision models that are trained to detect structures or corrosion. So we use them for detection mainly. And then we have LLM-based agents, AI agents that can help with various tasks ranging from authenticity check to condition assessments. And I would like to start with the vision models, the maritime aware computer vision. So maritime aware is something we talked about in the first slide. It's very important again. So our main product is based on predicting corrosion. However, this starts with an initial filtering layer, a surface detection layer to focus on what is relevant. So here we see two examples from actual inspections that we taken from our app. On the left, it's a main deck inspection, and on the right, we see a hedge coming inspection. And as you see, in both cases, the noise is excluded. So, what is noise in the maritime context? It can be sky, it can be the ocean, it can be ropes, sometimes people, but these stuff are not relevant for any kind of analysis, like corrosion analysis, for example. So, we would like to exclude them, and it is very important because with this exclusion, we ensure that our predictions are done for the actual inspection object only, and this helps our corrosion model focus only on what matters. And before we predict corrosion, we create a clean, segmented view of the vessel's surface. So there is no distortion from non-structural elements. Here we see the main deck and hedge combing, but we also apply this to pipes, hedge covers, many different structures. And so this is the first step, let's say. Nick, I'm sure you've seen thousands of inspection images before. Can you tell us why excluding the noisy background makes a big difference, especially in maritime world?
Yeah, definitely. And I think, as you've kind of mentioned, Amir, this forms the basis of everything that we build on, right? So where we think about these visual inspections happening on board, supported by photographs to document the condition. Obviously, when you take a photo, you capture kind of everything in the background. But as you know, as a human, when you look at something to inspect an element, of course, you scan over everything, but really you're focusing on a specific area. If we're carrying out this hatch combing inspection, that's really what we need to focus on. And that's why we've trained the models to do exactly that: segment, focus on just the hatch combing, and that way, when the results are analyzed, we can then give an accurate, let's say, condition assessment or extent of corrosion based on those specific areas. Sounds very simple, something that humans do intuitively when they are interpreting these results or looking at these pictures. But actually, this forms the basis of how we can then accurately generate the results, accurately predict the extent of corrosion, etc. So this is kind of fundamental in everything that we do and where we build on.
Exactly, exactly. So let's go to the next layer of this detection pipeline because this is the real product that we would like to present here, which is corrosion. Corrosion is our in-house corrosion detection model, and it combines the surface segmentation layer that we just talked about in the previous slide with an additional layer of segmentation model that is trained on hundreds of vessel images from Kaiko's own database. So as we all know here, corrosion is a quite difficult phenomenon, uh, like with many different forms, and can cause severe problems when not detected at the right time or when not maintained properly. There are many different corrosion or rust detection models online. However, the main problem with these models is that they are not aware of the maritime context. So we talked about this in the very beginning. It's very important. So we can think of like this. These models are trained on the images on web, and they can detect forest fires, but they need to detect cigarette burns in our case, so which is a very difficult task for them. So they fail. Our model learns from actual inspection data that are uploaded by Kaiko's own customers and labeled by our experienced maritime experts. And it is very important to underline that labeling corrosion is maybe the most time consuming and expensive part of this process because it needs to be done very accurately, and also the data set has to be curated effectively afterwards to include different types of corrosion. And also, once you have the data, it is not done. So we talked the importance of the feedback and the continuous improvement. And there's a process called active learning, machine learning, which means you pick new training examples based on the failure of your model. So your model is not capable of predicting corrosion in all edge cases, right? We have many edge cases in the maritime world. So you need to detect these examples. If you add more data that is already well represented, that won't improve your model. So that's why we want to detect these edge cases where the model fails, and we retrain the model using those examples. So here we have a video to show how corrosion works in practice. So you see a hedge cover here, and when you click on the corrosion, you see our corrosion prediction, and then you can give your feedback with thumbs up and thumbs down. So we picked this example because there are several things to talk about. Like, first of all, this is a spotted corrosion. So it is a tricky corrosion to predict. So the corroded surfaces are distributed. Second, the surface color is problematic. I say this because when you want to detect rust or corrosion, you don't want to have colors like brown, orange, red. So this is another challenge for the model. And also, the sunlight is strong. Of course, we like light when we have a vision model, but not too much. And this is also a challenge here. So it already shows that corrosion is capable of predicting this difficult case quite accurately. And with these feedback buttons that we provide, we gather this feedback from our customers, and we retrain our models regularly so that we improve our accuracy. Nick, I know you're an expert of different types of corrosion, and probably you know the best what kind of a pain undetected corrosion could lead to in a vessel, right? So you also work with TSIs, superintendents, and so how can Kai corrosion support these people when they're inspecting a vessel?
Yeah, great question. And I think that this kind of, again, is one of those fundamental elements, right? Like corrosion is everywhere on board the vessel. It's kind of inherent, and it's something that just needs to be managed effectively. But obviously, the first step is detecting it. And this is where the crew on board are working kind of day in, day out, doing these general inspections of the vessel, more generally in the specific areas, be it ballast tanks, cargo holds, etc. But it's obviously very hard to cover all areas of the vessel. And this is really where Kai can supplement this. So when these inspections are carried out, again, supported by photographs of all of these detailed areas, it's very hard for a human to go through and look through each one of these pictures individually, but this is something that can happen automatically in the background, um, and can be run on every single inspection image that's uploaded. So again, you don't need to spend time focusing on this, but this can be running in the background, and any problematic areas can immediately be highlighted. Again, focusing energy and attention on areas that provide the most value. And again, I think this is a great point to launch our second poll. So again, you'll see that pop up on the bottom of the screen. So here we really want to understand from you whether you've experienced challenges with unexpected corrosion and associated maintenance. So again, you'll see the options there. If you have in the specific areas, be it ballast tanks, cargo holds, cargo tanks, main deck, void spaces, other areas, or maybe not at all. So again, it would be great to get your input there. So we'll just wait a minute or so, and look at the results. And I can see immediately the results coming in here with in the ballast tanks. I think that's something that's not surprising, Amir. That's something we've seen pretty regularly here. Actually, this was the feedback from customers that was kind of the starting point for us to implement the corrosion module, because understanding the level and extent of corrosion in the ballast tanks, the complexity of these structures, and being able to monitor it constantly, is kind of almost an insurmountable task for an individual superintendent or the crew on board to do. So really enabling the tools to supplement this, make this process as automated as possible, and then really focus on any areas where corrosion might be detected early, so that actions can be taken to either rectify it, manage it, or maybe just understand the extent of it prior to going into a dry dock.
Yeah, I'm not surprised to see about the ballast tanks, so we'll always talk about them, and we will see them in a bit actually. So yeah, thank you.
Perfect.
All right, thank you for your answers, and we can move on to our next product, which is KaiSight. And speaking of water ballast tanks, so it's quite relevant here. So we use computer vision also to enhance images, not just predict things. And so some of the most critical areas in a vessel, like water ballast tanks, are unfortunately very dark, right? It's very hard to see clearly, it's very hard to inspect, and it's even hard to take proper pictures inside those dark spaces. And at Kaiko, we decided to tackle this challenge using KaiSight. So KaiSight is a photo enhancement solution designed for exactly these environments. It significantly improves the visibility in low light images, and it helps inspectors or crew members see details that would be lost otherwise. So here we see an example. On the left, we have the original image of a water ballast tank, and as you see, it's very dark, almost nothing is visible. And on the right, we see the Kai side version of the water ballast tank, and then, yeah, it's much more visible, much more clear, for inspectors and crews, this means less frustration, right? Capturing usable evidence, especially in these places. And for technical managers and superintendents, enhanced images mean more consistent and more auditable inspections, which is also very important for them. Yannick, we already started to talk about it based on the like poll answers, but similar to corrosion, I know you are an expert of water ballast tanks, and I know that we talk about them a lot together, and you know the best how challenging things can get. So yeah, why is SkySide mandatory for these inspections to support crew members?
Yeah, yeah. And I think probably there's a number of people on the call who've been inside ballast tanks know it's not the most hospitable space, right? And it's often dark, especially once you get into the bottom of the tank. So it's really hard to accurately capture the condition. And when we think about, Kaiko in general, the idea being, empowering the crew on board to carry out these inspections and giving the shore team, whether they're sat in the office, at home, traveling, that ability to see the actual condition of the vessel. And a key tenet of that is the photos, is the images of the actual condition. But when that's complicated and hard to capture in the ballast tank, with a smartphone or a digital camera with just a small flash, often this huge amount of work that's done on board inspecting the tanks can seem wasted because later, as you see, you have these dark photos. It's really hard to see anything, by the human eye. And this is where, enhancing these images means that all of that work that's done on board isn't wasted. The crew do the inspection, they capture as best they can the condition, and then we can still enhance the images and make sure that they're clear for the superintendent or vessel managers who are back in the office to really see for themselves. And when these is combined, it means you can really identify any areas that maybe got missed before, you couldn't see clearly, whether that's any indentations, any areas of corrosion, etc. Again, as Emir said, without the enhancement, you wouldn't be able to see this. You can't see that in the photos. But now with the enhancement, it's very obvious, easy to see, makes it clearer, make sure that it's easier to understand the actual condition of the tanks.
Yeah, yeah. And also, like as you also already mentioned, this is about not just like inspection, this is about the quality of the input for our models, for our AI models. So, as it was mentioned in the previous slide, there's a saying in the community, garbage in, garbage out. Maybe most of you already heard that. So if your input quality is low, you will get bad results, right? And we see KaiSight is a part of this like quality assurance layer in Kaiko in our pipelines. And similar to KaiSight, we have another tool that works for this, which is Kai validation. And this is another subtle but real challenge in digital inspection is verifying that the taken image is authentic. So it's a real world capture, not a reuse or copy. And sometimes by mistake, and sometimes to save time, crew members upload images taken off screens, right? We know that instead of taking new photos during the inspection. This could be an old photo shown on a laptop screen or even a screenshot or previous inspection. So this kind of behavior leads to, unfortunately, unreliable inspection data. And that's why we decided to build Kai validation. So it's an AI-powered gatekeeper that verifies every uploaded inspection image before it enters our AI pipeline. So we want to provide high quality inputs before we run our AI pipelines. And what this product does specifically, it looks for visual patterns called Moir effects, which are strong indicators that there is a screen image in front of us. With the state-of-the-art vision language models, we can reach up to 99% accuracy in detecting these effects. And here we see an example from our app, and Kai Validation detected a screen image, and we flagged this image with our banner saying Kai Validation noticed something unusual with the image, and we warned the manager or the superintendent about this image. And the idea is to, again, help and support these people in their daily tasks. And sometimes it's an honest mistake, but sometimes it's a potential shortcut. And if these people like try to verify hundreds of images in on a day or on a week, we know that human eye can get tired and it is not the best. But AI doesn't get tired, so we would like to support them and we would like to flag these cases so that they can invest their time in different tasks. And Nick, you know how easy it is to overlook these issues with the human eye, right? Especially as I
Yep.
said, if you have hundreds of images to check. So maybe you can tell more about how such validation could save significant time.
Yeah, definitely. And this is great because this is just that continual evolution of the product because one of our fundamental tenets at the beginning was that photos have to be taken live using the app on board to document the actual condition of the time. So none of this kind of using previous pictures that were taken and maybe saved on a drive and really ensuring that the actual condition is documented so that the shore team have that assurance that yes, this is the actual condition holistically of the vessel at the time and currently. And this is, as Amir mentioned, where we saw sometimes that the photos, although they're taken on the app, are taken of a screen, right? So again, it's this kind of shortcut, and that might be for legitimate reasons. Maybe one of the elements relates to, testing the loading computer, and they want to take a picture of the screen to document the loading case. That's absolutely fine. But where they're maybe doing safety inspections on board, and suddenly you're getting photos of a screen of a fire extinguisher or a life jacket, that starts to give some indication that maybe the inspection hasn't been done correctly on board or hasn't been done in a timely manner. And again, this can be detected, by the human eye, but doing this on a scale when you have all of these inspection points in the system is not an efficient way of doing this. So this again is this perfect use case of augmenting the system using AI to detect these issues. And again, as Amir mentioned, just flagging this because this can be the start of the conversation between the superintendent and the crew. Hey, maybe why didn't this inspection on board happen? Why didn't you inspect this item? Why were you just taking pictures of the screen? And ultimately, what we look at doing is catching these issues early so that there's not some snowball effect. And later, you don't have an issue with port state control or during your class inspection, which could ultimately end up in, a vessel being detained, having deficiencies, or having bigger issues down the way. Really understanding that inspections are completed correctly on board, the actual condition is documented, and therefore, removing any issues that could happen down the line.
Yeah.
And I think again, great chance to launch our third poll and third and final poll. So again, you'll see this pop up in the bottom of the screen, and we really want to understand from the audience. Have you had problems that you couldn't foresee because of these manual inspections that could be just ticks in a box, or actual like where we're saying, for instance, the actual condition not being documented? And is this something that you've experienced? Does this happen on a regular basis? And is this something that ultimately is kind of causing issues for you? Um, and again, seeing the results come in live, we can wait a few seconds, but I think already we can see yes, often, yes, once or twice are the most common responses there. So again, I think this is not unexpected, let's say. And I think Amir, as you've seen from looking through all of the results that we have in the system and training the models, this is something that's still happens on quite a regular basis.
Yeah, yeah, definitely. Look, it can reach up to 3-4%, like the screen images, especially for some cases, for some questions, for some particular inspections. So it's an happening situation. And as you said, our goal is just to provide the second opinion, right? Like it's not about detecting or like catching these things. It's about look, have a look at this. Maybe there's something unusual going on. Maybe it's totally fine. Maybe you want to see a screen image. Or yeah, I think it's quite important.
Yeah,
Right.
definitely.
Uh, so let's wait a bit more and then we can maybe start with our second group of AI products slowly. So as I said in the very beginning, we can classify our models in two main categories. So we have this class of vision models that do detection or like enhancement, things like that. And then we have our AI agents for various stuff, for filling checklists, for ratings, for summaries, condition summaries. And here we see an example of Kai checklist and Kai rating and how can they assist crew members in their inspection. So in our app, we have the hull equipment module and VHM, which is an interface for crew members where can they inspect vessel structures. They can upload images, they can rate certain vessel structures based on their condition. And here we see an example image in the upper right section of the slide. So that's a deck image showing corrosion, right? Severe corrosion, and it's not in a good condition. And the crew member took the picture, and yeah, they gave their own rating. But on top of that, we provide another second opinion here, similar to Kai validation, that takes the image and uh, puts it into a multi-agent pipeline that analyzes the image, fills a checklist, and gives ratings. So how does it work? We have three agents here. First agent looks at the image, identify the relevant context. So if this, like, is it a H coming, is it the main deck, is it piping, etc. And then it prepares a list of items, list of aspects that need to be checked for this particular inspection. The second agent takes this list, again looks at the image, and rates each individual aspect in this list and provides an image description for the final agent. And final agent wraps everything up. It takes the ratings, it looks at the image, and it understands the situation, and then it provides justification. Like it provides the very short one sentence summary of the condition with an actionable maintenance measure if necessary, And so we provide this list for our crew members, for our managers, so that they can have a look at it. Because sometimes, as we just talked about, human eye can miss stuff, so they inspect hundreds of images in a week, and yeah, technical managers need to verify. And yeah, we have all of these inspections, so we would like to provide Kai checklist and Kai rating as a second opinion, so that they can at least verify their results and the crew members' findings. And the reason that we did this with three agents instead of a one LLM is that we wanted to avoid the attention deficit, which is very likely in the maritime context. Because if you give the image and ask so many things, just check the image, fill the checklist, rate, write justifications, the LLM can do that. But we observed if we split this into three tasks, they perform much better with the almost same cost. So that's why we chose a multi-agent pipeline here. And yeah, Nick, like as was the case with Kai validation, we face a situation where a second opinion to support naked human eye could significantly help to catch problems. So maybe you can share your experience about undetected problems due to the busy schedules of crew members because they have to inspect a lot, right?
Yeah, definitely. I mean, this work is going on day in, day out, in addition to whatever cargo operations they have, port operations they have, particularly vessels on short schedules. So ultimately, again, this is looking at where we can assist the crew, assist the shore team wherever we can. And again, this builds on the kind of fundamental tenets in our philosophy. So really ensuring that we provide this data in a standardized way and kind of add this level of objectivity. So we try to do that as much as possible, already supporting the crew in these inspections, standardizing it in a structured way, providing the guidance, providing the guided and the structured ratings. And this then adds an additional level of objectivity. So we often talk about whether it's having your best chief officer, safety officer, chief engineer on board every vessel, or conversely, your best superintendent assessing every image, as it were. And it kind of works in that way to, again, automate this, provide this level of objectivity. And I mean, I think as you're going to show next, we can show you how this can then be supplementary to the results that are provided by the crew.
Exactly, exactly. So after presenting our products, we thought that it would be nice to show a proper showcase how that demonstrates how these tools that we developed can work in conjunction and can support the inspection process. So here we have an example from a vessel. On the left, you see the Kai summary, and there the summary detects an issue in the water ballast tank number 4, right? So in hull equipment module, you go to that section, you open the inspection. Let's start the video to see it. So what do we see? An almost black image, pitch black. So nothing is visible, right? So what do you need? You need KaiSight first. So we enhance the image in order to be able to see the problem. And bingo, when we enhance the image, we actually see the problem that is mentioned in the condition summary. And what do we see in this video? Let me restart and pause so that we can see that. So here on the right, we see ratings, right? And we see that crew rated this image with 4. So almost fair, good condition. It's not a surprise because the crew member couldn't see much as well, we assume. And yeah, he said, okay, this is okay. This looks fine. But Kai said it's 2. So usually they don't contradict. Usually, when the image is properly taken, we see a good agreement between Kai rating and the crew rating. But in this case, we don't see this agreement just because of the uh, condition of the ballast tank. It's quite dark, and the crew member, the human eye, cannot inspect as good as the AI. So, which is a really good showcase that proves what we just talked about with Nick. And yeah, we exactly talk about how challenging water ballast tank inspections are. And this is a water ballast tank inspection, and we show how we can tackle this challenge with just a few simple clicks, right, Nick? So maybe we can want to say something about that as well.
Yeah, exactly. And I think it's kind of essential to kind of reiterate here that this is happening automatically in the background with zero manual input, right? So as soon as the inspection regime is set up, the crew execute the inspections on board, upload the results through the system. All of this is running in the background. So we like to say this is happening, whilst the superintendent could be making their first cup of coffee in the morning, and really means that by the time they sit down, they have this actionable summary to understand exactly where any issues lie. And again, we talk about this level of objectivity, right? So of course you have your crew on board providing their assessment, providing their rating and their results, and this is that impartial third party rating as well. And again, as we can see, we can have different scenarios. Maybe the system detects something that the crew missed or was overlooked, but we can also have other scenarios where actually this gives you the confidence and reinforces the crew's rating. So yes, it predicts a similar result, which gives you that kind of confidence that yes, my crew are assessing these issues correctly. Or even a scenario where actually you have this objective rating that's better than what the crew rated. And really then you can see whether maybe your crew are being a bit pessimistic, rating it too badly. And again, it's just providing this additional objective viewpoint, additional data point, which enables then, the shore team to make their own assessment, understand the actual condition and what actions need to be taken.
Yeah, exactly, exactly. And let's move on. So we reviewed our products, the ones that are already in use and the ones that are already solve practical problems on many vessels in the world right now. But one thing is important to underline once again here, which is the importance of feedback. So I talked about it in the first slide, the expectation versus reality. So like every time you use Kaiko, either providing a crew rating or a feedback to corrosion prediction, you actively help us identify areas where our models need to improve and learn more. So I talked about this, like this is called active learning. And like imagine the space of possible maritime images as a configuration space, and your model knows some parts of the space, but it doesn't know some parts of it as well. So we need to teach the model the blind spots, let's say. And the most effective way to detect these blind spots is customer feedback. So, and we actively like gather this feedback and try to detect these cases. We prioritize them in the new training cycle. And instead of randomly trying to improve the model, we prioritize the cases where the model struggled most. So Kaiko's corrosion detection is a living, evolving tool in that sense, and as shown in this feedback diagram. So the more your teams use it, the more feedback you provide, the more accurate and reliable it will become. So when you invest in Kaiko, you are not just adapting to a product, you are also partnering in this improvement with us, so which is very important to underline once again. And maybe before we end our webinar, we are approaching the end closely. I see the time, so we can talk about future a bit. So we can review one of our upcoming products, which is about the famous SIRE 2.0 module. And Nick, maybe you would like to introduce this to our audience because I know you are quite expertise about this.
Yeah, and this actually, we had a question earlier in the webinar exactly about this. So I'm glad we included this slide and can talk about this a bit more. But this is just to kind of give a sneak preview, as it were. And again, just to demonstrate how we always build on actual problems that our customers are experiencing. So, our SIRE module has now been live for almost a year, our SIRE 2 pre-vetting preparation. And one of the key elements of that is preparing the photos required by the Chapter 11 photo repository to be provided to OCINF in advance of the vetting inspection. So again, this element of work being carried out on board, transferred to the shore, and then uploaded into the OCINF platform. And we already implemented not only guidance, but some kind of hard constraints within the act to try and ensure that these photos are taken correctly, in landscape mode, date stamped, etc. But there are other requirements that are harder to enforce. And this is exactly where some of these issues were identified. And now using AI, we can now do this direct comparison, right? So when the photos are taken on board, we make sure as far as possible that they're taken in accordance with the requirements, but we can then do this automated assessment, which basically ensures that the final photos that are uploaded into the OCINF platform are therefore in accordance with the requirements, less likely to have issues during the vetting inspection or having to request for these photos to be taken again on board. So again, it's another perfect example of identifying real world problems and understanding where we can use AI to really solve the problem and do this in a way that's automated. So it doesn't require manual input or checking, again, provides these data points, provides the actionable summary.
Yeah, yeah. Thank you, Nick. So I think this product, which is upcoming very soon, it is like really important to support our motto, our like mindset about bridging the gap between reality and regulations, because there are many regulations in the maritime world, as we all know. And yeah, things might be cumbersome sometimes for crew members to check all this, like to verify all of these regulations. And definitely that there's room for AI in these regulations. And yeah, one of the very important use cases popped up in SIRE module, as Nick already described it. What we basically do is to measure the similarity of your new image with the baseline of OCIMF. We use image embeddings and we vectorize our images so that it is easy to compare them with each other. And then we use vision language models to check for the criteria quickly. And so for the managers, it's a big help because we will automatically generate those findings if there's a problem in the image. So yeah, that's a big win for them in that sense. And yeah, we are currently getting ready to deploy this feature. And before we end, maybe we can have some words about our vision, our long-term vision. So where we see Kaiko is heading, not just in the Rex release, but in the long term. So as company, we would like to lead the maritime tech industry. And first part of reaching this goal will be establishing our vision for the future. So we see proactive workflows as the next leap. Instead of just reacting to findings, we want that our tools to start noticing patterns as well, like predictive maintenance, kind of. This can be recurring minor issues in specific areas, rising risk trends, even missing inspection steps. And from there, we would like to suggest new checklists, draft maintenance reminders, or early warnings. Of course, all of these with the crew still in command, as we talked in the beginning, so human in the loop. And second, we want to have smart vessels with living memory. So what does that mean? Today, the inspection knowledge is very fragmented, often stored across different databases, different modules. But we want that every vessel to maintain a versioned, secure timeline of its findings, repairs, condition, always accessible, always audit ready. Imagine being able to instantly see whether an issue in a ballast tank that we looked at has happened before, or what was done for maintenance, and whether the issue is recurring, etc. So this will be a big strength when we have it. And finally, once we achieve these things, we will be able to speak of what we call maritime general intelligence. So that means developing AI that does not just recognize corrosion or fill checklists, but developing an AI that genuinely understands the maritime world. An AI that knows your vessels with all their structures, understands inspection logic, can connect the dots across inspections, across reports, and even across fleets. So, but for this, we need better models, better infrastructures, and most importantly, more data coming from Kaiko users that will help us build this super brain. So, as we just talked about in the feedback slide, the more you use Kaiko, the better we will get and the faster we will reach our goals, hopefully. Yeah. Would you like to say a few words about our vision, Nick, as well here?
Yeah, and yeah, I think you provided a great summary there. And I think the only thing I wanted to add is to say that, this is now fundamental to everything that we do. And time again, we implement the structured data set, understand kind of where the problems lie, and then look at exactly what we can automate. So it's not just nice to have, but this becomes something that's fundamental to everything you do, supplementing what the crew do on board, supplementing what the shore team can do, ultimately kind of reinforcing, making sure that everyone can do their job better, more efficiently, safely, and that the vessels can maximize the uptime.
Yeah.
I think we are just running into the last minute or so. So just to touch on a couple of questions. We had questions that were asked throughout the webinar. Thanks very much for the input. Great questions from you all. And we answered some as we went along. But maybe just to touch on the last couple, is there a specific number of photos that need to be uploaded for a particular structure in order to let the AI process it? Amir, maybe do you want to add something on that?
Let me open the question again. So is there a specific number of million photos? No, like because the training process is happening beforehand, right? Like when we come to prediction, the model is already ready. So doesn't matter how many inspection images you upload, each inspection image will be treated separately. So let's say you inspect the hedge coming and you took 3 different angles, 3 different pictures. Of course, the one that was better represented in the training process will be predicted better. You know what I mean? So if you take one of the images with a very narrow angle, that corrosion prediction might not as you like. But if you follow our instructions that we give during image taking, like we also give these instructions, so where you have to sit, where you have to stand to take the picture, and if these are followed, one single image should be sufficient to predict corrosion for us.
Yeah, brilliant. And just another one that was about pitting in cargo tanks. Mentioning that you really need to measure the depth of the pitting to understand the status of the tank. This is a great point, and I think this is something that we mentioned time and time again. We're not replacing the human on board. Having been a class surveyor, I think you can't replace, a close-up survey standing hand's length away from something. But this again is really looking at how you can supplement what's being done. So the crew are still doing this inspection themselves, but this is really providing this extra level of insight, extra level of data, maybe where the crew missed that there was any pitting. Of course, if you really want to understand the exact extent, that then needs to be measured. But maybe the pitting was missed in the first place. This gives you the ability to not only detect it, understand the extent, and then really understand maybe where you need to focus more on that area. Even yourself as a superintendent, when you visit, having this summary to understand, where do I need to focus my efforts, my energy when I have that limited time on board the vessel, to really understand the condition.
Yeah. Yeah.
And I think there was a couple more questions. So we're running out of time now, but we will answer those in the follow-up and provide answers to all of those. I think last thing says that's really all we have time for. And thanks so much for joining us. I hope you found this as interesting and informative as I did. It's always great to speak with Amir, and I'm glad we could kind of share this conversation and have this live in front of all of you. So as the kind of last comments, you'll receive an email in the next hour from to book a call with the team if you would like to learn more about this and follow up with us. Alternatively, if you do have any questions, please feel free to reach out to either Amir or myself. Our emails are here on the screen. We'd love to hear from you with any questions or further comments you have. And lastly, just to say thanks once again, and we look forward to seeing you during our next webinar.
Thank you so much, guys. Thanks for
Have a
joining.
great day.
Have a great day.
Bye-bye.
Bye.